them to check it out.
Mm-hmm.
So, anyway, ladies and gentlemen, this is Yarek. He's a good friend of mine and all of us here. And he's been working on some great software tools in order to enable and help people get ready access to a lot of different neuroimaging tools, which at times can be very difficult to install. And he's come up with great ways of doing that. But he's also come up with great ways to share data with Data Lab. So we talked a little bit about GitHub yesterday, and people were very interested in how GitHub and Git, maybe more appropriately, can be used to handle data storing, data sharing, data revision and stuff.
Mm-hmm. Okay, maybe I'll start my presentation from the presentation, and let's see if screen share would work correctly on my desktop. Start screen share. You're presenting. That's good. So you see infinite window, right? Do you see anything? Yes. Okay, good. Great. Let me get to the slides, and I hope that you see them. If not, buzz me anyhow. So I took this talk from another talk which I gave recently, and before anything, I just want to thank everybody who anyhow participated. Like Michael Hanke is my close collaborator, and I wouldn't say that I came up with NeuroDebian. We came up with NeuroDebian a while back, and many people were involved, and we use lots of free and open source software in our not only development but in our scientific research work. That's why I wanted to thank every developer out there who developed those wonderful tools, and I want to thank our mentors. And once again, this talk is a part of a bigger talk, which I gave recently. So if you want to discover, learn more about projects I'm leading in method development or software development, like the PyMBPA project for statistical learning analysis of neuroimaging data, then look at this full talk, which is URL for which given is at the bottom. And slides for this talk are present from another URL. So if you want to download them to your computer, you're welcome to do so. And since you mentioned Git and Data Lab, maybe I'll give even brief demo at the end what Data Lab is about. So let me start with talking about NeuroDebian. So as many of you know, most of the research software is not rock solid. That there are many problems, especially if you try to support many platforms which are out there. Quite often we have difficulty to even report about those problems which we encounter. It might be painful, time-consuming, and that's not surprising because most of that software is developed by students and maybe just volunteers who might be lacking professional programming training and experience. And insufficient testing kind of contributes to that, but most problematic one is death by PhD phenomenon. So as soon as that student graduates, that software might go unmaintained or just disappear from the any public portal. And partially those problems were mitigated now with such portals as GitHub, which kind of provides not only immediate development platform, but also archiving. So you could always find a history of the project and get access to it and maybe clone it and maintain longer. But it used to be that there were no, even for many projects, there were no public version control system. It still remains a fact for many initiatives, but I would say majority of the projects now became available either GitHub or Bitbucket or some other code sharing platform, and those come with bug trackers. So situation is quite better now, but I would say it's not completely resolved. But we cannot blame those developers for who develop scientific software, because the problem is that it's really hard to obtain funding for developing software which implements some methodologies, because people won't really, grant people won't really to fund proper research, right? Not developing software which implements those methodologies, which actually, but they all demand reproducibility and all kind of related aspects, right, which couldn't be achieved without sharing software, especially nowadays with all these buzzwords about data science, right? Data itself without software, it just bites. You cannot do anything with it. So software remains really crucial for research activities, but I think it's underappreciated. It Many people consider it to be a solved problem, which it is not. And another problem, not only lack of funding, but it's development of scientific software is rarely considered to be a scientific progress, which again kind of attributes to the difficulty to obtain funding for that. So projects go usually more like a toy projects for people. So, but what do we want really to progress, propel our research? We want to use recent tools, right? We want to get access to the bleeding edge technology and stay connected with the field, right? So we want to have latest tools and to produce more interesting research and more interesting publications. But we don't want to lose results with a new version of for mysterious reasons, right? So we could lose results because software became buggy, because feature went away, and with those upgrades, right, we might just become to run unstable system, and we don't want that, right? We don't want to waste time on maintenance of the systems. So why we can't bother with upgrades to happen every day? Because it's usually takes a lot of time. In publication we've done a few years ago, we published the results of the survey, which are, by the way, all available on GitHub. So if you want to do some meta-analysis in those, you are most welcome. Apparently, on average, neuroscientists on Windows spend around 14 hours a month on non-research maintenance tasks, because probably Windows lacks, or well, it still lacks any ecosystem to maintain heterogeneous collections of the software. And upgrading usually quite often requires, if you just got your software from different sources, it requires downloads, extraction, reading documentation, running various scripts, if you want to use more than just WordPad and calculator. So, but we need these recent versions, right? We want to get new features, and to be efficient, we want bugs to be fixed, right? So why don't we use all the same platform? Well, which is somewhat utopian, but this is what we are trying to provide people: some homogeneous platform which runs on all devices, operating systems, and that is guaranteed to be available as long as you want and wherever you want, and which you could share easily with anyone, let's say your collaborators or your friends or whoever, or maybe with your students if you're teaching. But the system also which makes maintenance quite trivial, right? And where all the software necessary for your research activities is available in a single environment with the same commands to install it. Not that you need to go to different updaters all around, but there is a single source where you get your software. And so we could share this with our colleagues, collaborate more efficiently, that maybe we could share data and data processing workflows also really easily. And then developers hopefully can focus their scarce resources on doing actual research for which they were hired, and not maintaining the systems which they developed the scientific software on. So we decided to come up with a project NeuroDebian, but for the role model was taken Debian project. And both me and Michael are official Debian developers. So we had experience with Debian since probably 2004, 2002. Actually, in my case, I started to use it in 2000 as soon as I came to the States, which was completely alien thing to me. Before that, I was all Windows user and Delphi programmer. So what Debian is, first of all, it's a vast archive of maintained software. There is over 30,000 binary packages. What we meant with maintained software is that it's not just source code, that it's not only binary dumps of some software. It is packages which are maintained by the package maintainers, and if you have any trouble with it, you could report a bug and it will get fixed. What is specific about Debian in comparison to possibly other distributions, that it's completely self-governed. There is no company behind. It's only people who participate in this project, and it's driven by principle of democracy. If you want to have something done, just do it, and then you'll become the authoritative person for that project. And say if you are maintaining a specific package, you'll be the responsible, but also the one which people listen to whenever decisions about that package come about. And theoretically, well, or practically, it's been out there since '94, and all those developers, well, many of them have their pretty much main work job is to package software for Debian if they work for some corporation, but majority of the developers, they just hack Debian just because they like it and not because they can earn money from that. And it's been going that strong for 20 years now. So whenever you hear that, oh, but what if it goes away in 2 years? That's unlikely. And what is also interesting that if you look at the software distributions, which are primarily Linux-based these days, it's actually the basis for a majority of them. Many of you might not have heard about Debian, but have heard about Ubuntu or Mint. The truth is that Mint and Ubuntu, they come from Debian. So on this tech cloud, you could see different Linux distributions according to DistroWatch, scaled according to their popularity at the DistroWatch. Although it was generated a few years back, I guess situation remains the same or even more in favor of Debian. So all the reddish colors, this is distributions which are based on Debian, such as Ubuntu, Mint, well, Debian itself is based on Debian, Crunchback, Lubuntu, any derivative, kind of, it comes in here. And there is over 130 of them. So it's quite easy to do a derivative of Debian, but that's not what we do with NeuroDebian. We don't call ourselves derivative because we work within Debian. Whatever we are doing for NeuroDebian, package the software, the end goal is to upload it into Debian. Because by that, we are adopting technology, procedures, infrastructure for the work we do, right? So we benefit greatly from what Debian provides. Let's say build infrastructure across 12, I believe, or more architectures, which is none other software distribution is capable of at this point, or not providing those services. And then we could also benefit from work of all those thousands other Debian developers or contributors, right? Quite often we get contributions in the sense of translations for user interfaces, which we have in our software, or bug fixes. So many of those contributions come back pretty much on top of our work. And originally it was called Experimental Psychology Project in Debian, but in 2009 we came up with a new name, and it was simple, NeuroDebian, and a fancy logo was created. So that's how was NeuroDebian born in 2009, although our activities initiated pretty much around 2006, when we took the software which we used in our research, which was FSL and PyEPL. For stimuli delivery, PyEPL, for data analysis, FSL, but we didn't want to maintain those separately on every desktop or server which is under our kind of duties, right? So we wanted to centralize that. That's why we packaged those tools for our own needs and made them available for others. So this is so-called cost sharing, right? So work we've done, it wasn't just wasted for our own good, but it became available for others. So all this sharing of the cost for maintaining systems pretty much got shared with the others, and we started to benefit from others who contribute to Debian as well. If you want to know a little bit more about why and how, we published a paper a few years back, Open is Not Enough. So you could read that one. It's open and available online. So what is NeuroDebian actually from a researcher's perspective? And I will hopefully demonstrate these live, that you could install any software as easily, regardless of its underneath complexity. Let's say in the first line, we're installing simple editor, which is simple binary, as easily as really heterogeneous analysis package FSL, right? So just one line when you installs both of them. Moreover, there are collections of software which bundle together software for a specific field. I wouldn't say that you would use them often because you don't want, all the packages for psychophysics. If you're using PsychoPy, you would just install PsychoPy. But it's possible to install these wide collections targeting for a specific field of science. And then you could keep this system up to date. So with single or two commands or button click, you could keep this system up to date. And if you're running, let's say, Debian stable release, you have a guarantee that with the upgrade, it will not break anything. We provide support channels such as NeuroDebian users mailing list and IRC channel on NeuroDebian. So there is lots of fuss about reproducibility, and I just wanted to give this brief, not demonstration, but a slide which demonstrates how easy it's to achieve reproducible environment from way back. So if you run this command, which invokes debootstrap, which allows to construct Debian environment from their archive. So Debian maintains this archive of releases, which go all the way back, I don't remember even which date. And you could take this archive of packages and say to debootstrap to initiate such environment and install packages which you need. Then you could use really lightweight virtualization technologies from 80s, Truth, and with a helper utility as Truth, you could create that kind of jump into that environment, and then within a minute, pretty much, it depends how fast your internet is to establish this environment, you could get back in, old ages. So if you want to reproduce somebody else's environment where you know that they've used Debian this release and use those tools from Debian, it's really easy. What we provide in NeuroDebian also is the virtual machine. So instead of going to archive and installing everything from the past, or instead of installing Debian and Ubuntu and then putting NeuroDebian on top natively, we provide virtual machine. Many of you probably familiar with virtualization these days because it doesn't restrict you really much, because virtualization is supported now in hardware. So running virtualized environment often is as efficient as running software that system natively. So we provide virtual machine with NeuroDebian, which comes not pre-installed with any software, but provides just a bare image. And I'll demonstrate how easy it is to install it within VirtualBox. And then you could install any additional software within it pretty much within minutes. We use it for teaching. Let's say this is the photo from PineVPA workshop we gave last year. And they were provided, students were provided with the laptops, but to not bother with native installation on Windows, we just provided this virtual image. They pre-deployed it across all platforms, and of course, as in best traditions, new release of software needs to come up right before the workshop. We released in the middle of the night, previous day, new version, and they all had to upgrade. So they all had to type just one apt-get update, apt-get upgrade line, and they've got most recent release, they've got most recent update of the data we needed for the workshop, and everything went smooth. So it provides this really nice way to organize teaching without sacrificing time for, oh, please install this tool, that tool, or upgrade now. Everything could be done really quick and seamlessly. And most interesting that then they could take this virtual environment and carry it with them home, right? So as it was in the course, although these weren't their laptops, they could export this appliance, take that appliance home, import it there, and they have exactly the same environment as they left while they went through the course. So what we have in NeuroDebian, we concentrate our activities on packaging software which is related to neuroscience, primarily neuroimaging, because that's our domain of expertise. But also we are Python shop. That's why many tools which we need ourselves are Python-based, or maybe some software which of interest for general computation as, let's say, where's there is Condor somewhere. So that's portable batch system pretty much to schedule your computational tasks on homogeneous or heterogeneous even computing environments. Also, we maintain many statistical toolboxes for Python, like stats models or pandas, as you might know. So those we upload to Debian and also to NeuroDebian. So let me actually first show you the feedback that some people really appreciate these efforts, and just going back how difficult it is to get support for software development in the science. So many people really appreciate the efforts, but some others, they say this is not as valuable as developing fundamental advances in neuroimaging software, right? So just keep in mind that when you're jumping into software development in science, it still remains really difficult task, even probably more difficult than research itself. But it's really appreciative, I would say. So it's really great to see that many people who which get inspired by our work and then contribute back into open science. And Neuron Debian popularity statistics, which are available on our website. These are anonymous submissions from people who decided, okay, I'll tell NeuroDebian and Debian that I am using it, and this is the package softwares which I'm using. So whenever you install Debian or Ubuntu or NeuroDebian virtual appliance, it will ask you, do you want to participate in popularity contest? I would certainly encourage you to say yes. Those submissions are anonymized. No unique key is generated for you, and only that one is submitted. So no name, no IP address, only the unique key and list of packages you have. So we have quite a few users, and this one is already probably outdated. This is still 2014, and we got even more mirrors now, I believe, in China. But what NeuroDebian about underneath? First of all, it's testing. So whenever I was talking about this sharing, cost sharing, this is, I believe, is of paramount importance, because we need scientific software to be reliable. And what we do while packaging new software package in NeuroDebian or for Debian, we enable build time tests. So if your software provides any unit testing or regression testing, we are trying to enable it at the package build time. Then whenever we build it across all distributions of Debian or Ubuntu, or within Debian across 12 platforms, those tests get run. So thus anybody who develops software could benefit as much. So running tests across all Debian and Ubuntu platforms on 64 and 32-bit, and then to run tests across 12 hardware platforms, pretty much. And some people say, oh, but I don't care about those tests on Spark platform, which I don't use because it's ancient. Well, first of all, Spark platform is not ancient. It's just not commodity because it's somewhat expensive, right? Or let's say X390, which is used just by big mainframes. But what interesting comes out of it is that some tests which are fail on those platforms are not because problems of that platform, but because of triggering the corner cases in the code which are not tested on conventional platforms, which becomes really interesting bugs. If you are into bug hunting, some of those are just great. Sometimes you found bugs in NumPy and SciPy which got triggered because it wasn't testing for the largest number condition, and then things, because of big endian platform swapping the bytes around, the next byte was leaking into the next number. And if it was just 0, it would have been leaking just 0 on little endian. On big endian, it triggered the bug. It was troubleshooted and committed back, fixed back in NumPy and SciPy, but originally detected on big endian platform. Then sometimes you're trying to introduce additional tests into the pipeline, let's say, to make sure that that package installs and deinstalls correctly. So to make sure that those interoperability also between the packages works out really nice. So if we maintain some core library, if, let's say, Cython, before uploading Cython into Debian, I run rebuild of all the packages which depend on Cython, then checking either anything got broken. This allows me to go kind of ahead of the train, right? So not upload Cython and then see how those hundreds of packages get broken, right? And then users get negative experience. But we test before that, right? So we build new version of site and we build all dependent packages, see which broke. If there is only few, then we report those bugs to corresponding maintainers and upload site. And meanwhile, if it breaks a lot, then we don't upload that package. So user systems became unaffected. And what we do in terms of packaging. So we mentor contributions. If you have your own library or package or just want to contribute somebody else's package, we provide mentoring. So we guide you through the process of packaging, how to package correctly for Debian, satisfying Debian policies. And then we sponsor this upload into Debian. Then we maintain those packages. So we respond to bug reports, proxy them to upstream, and make sure that the code remains portable across those platforms. And what is actually one of the most important aspects, which is completely disregarded by many scientific community or developers, is actually legal checks. We cannot provide law services as lawyers, right? But at least we could check that whatever software we upload into Debian, all the licenses stated they don't conflict with each other, that code doesn't incorporate some code snippets which are not redistributable. Why is it important? Remember I showed you the snippet how we could create the environment from 2002. This would remain possible only if those packages wouldn't be found infringing somebody else's copyright or license. It quite often happens that scientific software is just compilation of snippets, let's say, from numerical recipes book. Guess what? You cannot just blindly copy that code and pasted it into your software, because that code is released under non-free, non-redistributable license. The code in the book is only for demonstration and educational purposes, so you need to rewrite it on your own. And those cases are quite often. So if you want to guarantee reproducibility of our results later, we need to guarantee that whatever we are making publicly available will not be jeopardized later and would be required to be removed from online. I will not give you examples concrete to not point fingers, but those cases happen quite often. You could just go to snapshots.debian.org, which creates snapshots of archive twice a day. And you could see those bug reports which demand some software being removed from the snapshot because some code snippet or some images or something which was violating the license of original provider, which were violated. So that software has to be removed from online. So please be cautious about the licenses which you use. And also we provide modularization. Probably it wouldn't come as a surprise to you if you are always asked, let's say, for scientific software package to download a gigabyte tarball, right? Which would come with everything necessary for running it. But the trick is that majority of it is not changeable, right? So let's say those tarballs often contain lots of data, like atlases, which remain the same across all the releases of that software. So why to bother uploading this huge or installing these huge tarballs whenever we could modularize and split separate pieces apart? This would guarantee that we can fix one piece or upgrade one piece independently from others as long as they stay compatible. So that's what we are doing when we are starting to package some package. We look which third-party libraries are used, package those separately, or use the ones which are already provided by Debian, and also separate data packages into separate repository. So because they could be used without rebuilding across all the platforms. Okay, and then we provide our repository on top of stock Debian or Ubuntu repository. Why is it done so? Whenever Debian or Ubuntu releases, those stable releases cannot be changed besides fixing the critical bugs. So we provide our own repository, which provides backports of this recent scientific software, which you could install on top of your Debian or Ubuntu release, which is still supported by Debian or Ubuntu. That's why we are not quite derivative, but we provide something on top of Debian or Ubuntu. That's why we sit somewhere in between. We don't have our own installer. You just can take any Debian or Ubuntu release or their derivative, which doesn't rebuild everything, but just uses Ubuntu or Debian archive, and put NeuroDebian on top. So from Debian, in Debian, we also participate in other blends. It's so-called teams within Debian, which provide custom view over Debian projects such as Debian Science, Debian Med. We use their, because we are Debian developers as well, quality assurance support, bug tracking system, archives across those 12 or more architectures. But also by uploading to Debian, we provide the largest possible dissemination, right? Because we upload to Debian, from Debian it gets into all of those distributions. So it becomes available to millions of Debian or its distribution users. And we participate, as I said, on mailing lists, IRC. We have Twitter accounts, so you're most welcome to follow us. We have Insider blog, which we somewhat underuse, but those articles come back useful when we need to deal with specific problems. We host conference booths to provide exhibits like we did at SFN this week, and talks like I'm doing now, and stalking, well, that's what I'm doing now partially as well. But once again, we are providing this virtual machine, which is really important, I would say, because it's makes it NeuroDebian available across all the platforms imaginable, besides maybe cell phones, although I used to run Debian on my cell phone too. So it's compatible with Windows, Mac OS X, maybe anything else what VirtualBox supports, or it becomes, if any other platform becomes available, probably will come out with virtual machine there too. It's really interesting solution also for reproducible research. If you manage to do your analysis all in virtual machine, whenever you publish a paper, you could either export that appliance with all the data, with all the software, and just put it on your hard drive. Storage these days is not a problem, right? So we could all buy 4 terabytes hard drives for $100. So you could dump your entire machine, which will not be even, I don't know, it definitely will only be 4 terabytes unless you analyze some big data sets. And then keep it there. If somebody comes back that, oh, how can I reproduce your results, right? Here is the complete environment with all the software pre-installed, with all the data as it was when it was published. And we use also it for teaching, and it also makes all this effort kind of portable across platforms. So who is NeuroDebian for? If you want rock-solid operating system, which is Debian known for, and if you want readily usable and latest software at your fingertips, that's what NeuroDebian is good for. But also if you want to try something new. On my personal, well, not personal, but work laptop, it's no-brainer to try something new from NeuroDebian, or from Debian, or stock archive, or if it comes from NeuroDebian. I just install it, and I could try it. If I don't like it, I remove it. So it doesn't take me any time, pretty much, to install the software. And then we could, so you could try something new without, paying too much time for that effort. And we also offer students a fully functional takeaway research environment, which they can then either deploy at their labs or just use on their own laptops or desktops. We can officially collaborate with other researchers. We just provide this virtual machine or ask them to install NeuroDebian. Then we get exactly the same version of the scientific software. I don't maintain computers pretty much. It just works most of the time. What I invest my time into, though, is packaging work, right, and maintaining the packages. So, but then I benefit greatly from this maintenance and tasks which other Debian developers do. So it's, again, this sharing of the responsibilities without duplicating them, right? So it's not like everybody spends time on installing software and making sure that it works. Just some maintainer does it once, and then the whole community benefits from it. And if you package your software for Debian or NeuroDebian, it becomes as easily available for others to use. So if you want to reach maximum kind of large audience, that might be the good channel. And also, it allows to develop your software without worrying about the dependencies. So if you depend on many developers, they try to stay lean. in what libraries they use, because deployment then is difficult, right? If it depends on many libraries, you need to bundle them somehow. And with Debian, if those libraries are available on the system already from the Debian archive, you just say that I depend on those, and it works like charm. So get involved, find, evaluate, and report bugs. Join mail lists, read our blogs, send us tests, spread the word, and there is always help is very welcome. So that would complete my talk. And now I would say I could give you a quick introduction into this virtual machine. And I hope that we are still online. Seems to be Cameron left. He couldn't sustain this. But I hope that I'm still there. So let me demonstrate just my desktop. It's running GNOME environment. So what Linuxers are great for is that there is variability, and you could make your own choices how your environment should look like. So this one is GNOME 3. It comes with handy features like multiple desktops, which you could see on the right. This one depicts on the left on the software which I'm running currently. And I could easily find software which I need to run, which is VirtualBox. So I'm starting VirtualBox, and as you see, I already have quite a few of these complete machines are available pretty much for me if I need to, let's say, troubleshoot our development of DataLab on Windows. I have entire Windows machine in here, so I could run it. At some point, I had to troubleshoot CentOS 6.3. I have a virtual machine right here. I could run that virtual machine in no time, just double click. And actually, to make it maybe, if so, you could see what I'm typing if I start typing at some point. All right, this one doesn't work. Oh. So much of a demo. I just wanted to present you with key process, which I'm doing, but doesn't want to cooperate. Okay. So I have already NeuroDebian virtual machine imported as a safeguard if something goes wrong during my next presentation, but let me just show how do we import NeuroDebian virtual machine. And for that, we'll go to the browser first, and we go to neurodebian.net, which is our main website. And the section on installation, or get NeuroDebian, it provides the simple selection box. Michael is currently working also on new web interface design, so it might look a little bit different in the soon, but it will be as easy. So you just need to select your operating system, and as you can see, there is Windows, Mac OS X, but also set of those Windows and Debian and Ubuntu releases. So if you are already running Debian or Ubuntu or any of those derivatives, you could just enable NeuroDebian repository on top of yours. For that purpose, you select specific release which you are using, and select the download server, which will provide, it's one of our mirrors which are available around the globe, and you better choose one which is closer to you, so you don't waste bandwidth for transcontinental internet connections. In my case, it's Dartmouth College. And then you choose what component of Debian or NeuroDebian you want to enable. Debian comes with 3 suites. One of them is main. Main is where all the software is DFSG compliant, or that's a typo. I need to fix it at some point. So DFSG is Debian Free Software Guidelines, which are well respected. If you go to a Wikipedia article, any license, it will tell either that license is DFSG compliant. That compliance guarantees that this is really free works, so you could redistribute them or derive from them without any fear that you're violating somebody's license. Or you could choose, let me redo this, or you could choose all the software. Then it will include non-free, which might be free to redistribute, but you couldn't use it for commercial purposes, which is surprise maybe for some of you, but this is the license of FSL. That's why to install FSL, you need to choose this all software choice, and you need to guarantee that you have you have non-free enabled on your desktop, either Ubuntu or Debian. And it also includes contrib suite, which is packages which themselves are free, so they are under free and open source licenses, DFSG compliant, but then they depend on something which is not free. Let's say NiPipe theoretically could have come into contrib suite because it depends on FSL. It provides access to FSL, but it's only optional. That's why it comes from main, and you could get NiPipe only, even if you select only software with guaranteed freedoms. And then you cut and paste those two lines on your Linux, on your Debian or Ubuntu Linux, and run this command, and that's it. That's how you enable NeuroDebian repository on top of your Debian or Ubuntu Linux. But let me demonstrate how we do with virtual machine. And for that, you choose either Windows or Mac OS X. Again, select mirror, let's say USA, New Hampshire. And then you're provided with the URL to download the virtual appliance, which you download. In my case, I have already a copy or two. And depending on your bandwidth, this one takes around 600 megabytes. So it might take a little bit of time. Then you fire up your VirtualBox, which I've done before, and you import that appliance into the VirtualBox. So you choose your appliance, which was in downloads in my case, I believe, which is downloads. Why doesn't it search by documents, Dropbox? Do I have downloads? Oh no, it's right here in my home directory. Here is NeuroDebian 800AMD64. So I have selected which appliance to import, click next. Here it comes me with a choice already to adjust. I had already one imported, so it added _1 suffix here. I could say that use up to 2 cores of my CPUs. So if you have multi-core system, as many of you do, or pretty much probably everybody does these days, you could allocate as many cores as you have available to the virtual machine, so it will expose them inside. And then you could provide, specify how much memory to give to that VirtualBox. Let's say in my case, I'll give around 2 gigabytes. So you might want to leave some for your main operating system, but otherwise, you could give as much memory as you wish. And then you import that appliance, which just says that all the software which you install is under the Debian Free Software Guideline compatible licenses, but there are some which enable this non-commercial research-only software like FSL. So you agree. If you disagree, then you would need probably to take just original Debian or Ubuntu VirtualBox or appliance, and you enable NeuroDebian on top with only main component. Then you will get only free pieces. So now we imported new appliance, which is here listed as NeuroDebian 800 with _1, and we could power it up. And then you will be welcomed into default kind of booting screen of grub, which happens on Debian, and the boot process continues. It shouldn't take too long. But now we are booting complete machine, pretty much complete computer on your, in my case, it's at my laptop. The only trick is also that you might need to enable hardware virtualization in your BIOS. So if your laptop or desktop has that disabled, you might need to reboot, enable it into your BIOS, go in your BIOS and enable it, usually just a checkbox. Now we've booted fresh virtual machine with NeuroDebian, and it just will do few steps like this one will update the list of available packages. Then you could say yes or no. In my case, I'm okay to wait a few minutes. It shouldn't take actually a few minutes. It depends on your bandwidth, of course. See, so now we are getting to this dialog, which warns that next you'll have a chance to participate in this popularity contest I was talking about, and what it is about. So this comes from DebConf popularity contest package itself, and you could say participate or not. let's say, I say participate for as long as virtual machine exists. And then for some packages like FNI or FSL, do you want to enable those environments automatically whenever you log in? So you could say yes or no. If you're not going to use the FNI or FSL, it's as well, you could say no. And then we provide a list of pre-crafted bundles, pretty much, for installing some scientific software so you could start working easily. Let's say if you're interested in Python scientific stack and click here, it will install a few megabytes, well, a few hundred megabytes of scientific software which is related, which is Python and Python related. It will install IPython notebook for you. It will install pandas, stats models, I believe all those. If you are keen to learn our PyMVPA, you just click here and you install PyMVPA tutorial, which is just one line underneath this, which installs PyMVPA tutorial data, and you're ready to go. Or let's say if you want to work with graphics, let's say Inkscape, which is yet another typo. So great to give demos. So we have Inkscape typo here as well. And it will just pre-install those for you. And many people, let's say, have difficulty installing LaTeX, so TextLive would be the one to choose. So in my case, just for the sake of demo, I will not do any of those to not wait a while. But what I can demonstrate now is how to use this system. This system comes with Debian stable with NeuroDebian enabled on top. And we provide some virtual machine tutorial video on YouTube if you want to pretty much rehearse whatever you saw today, or maybe see some other tricks. And so this one is stable Debian, which comes not with GNOME, how I run it, GNOME 3, which I run on my desktop, but a little bit more lean desktop environment, which is called XFCE. So it has similar menu with what is available inside this VirtualBox Debian installation. And one of the interesting features, I would say, is our helpers for some of the software. So if you go into NeuroDebian folder here, first of all, you could go through the same setup wizard as you saw. If you decided, oh, let me try PyMVPA. So you go to Virtual Machine Setup Wizard, and at the end you click PyMVPA, it will install all this stuff for you. Or you could just go into those which we have here. Let's say psychophysics, we have PsychoPy here. And absence of icon here says that this software is not installed. We just installed bare Debian system with only core components. But I could click here, and what happens, it says, okay, to run PsychoPy, we need to install that package, and it will need so much of space. You click OK, it does its job installing the package, and there is high guarantee that it will succeed, because this environment is well tested, and PsychoPy installation was kind of ironed out, so everything should work nicely. It just takes some time to install things. But otherwise, it's just standard Linux environment. You could run your terminal. Thanks for multitasking. Okay, let's keep this one afloat so we know that it's finished maybe at some point. And this is the terminal, which is a standard terminal, I would say. But let me demonstrate command line maybe utilities for how do we install and search for software packages. Let's say we know that we want to, app cache is the tool to search in command line or show information about package. Let's say show PsychoPy. That will provide me information, description, and I could scroll with my mouse up, which provides also dependencies. So what is happening now here, I'm installing all those dependencies which PsychoPy needs. Python, Pygame or Piglet, probably it's installing Piglet because it's first one in the list, NumPy, SciPy, Matplotlib. And also by default, all those recommendations are installed too. So depends is really strict requirement for the software, but recommendations, this is optional. So that's when software could work without them, but ideally they should be installed alone. So, and here we go. We started PsychoPy. It will do some tests, initial tests. And of course, VirtualBox is not the way to run psychophysics experiments, because refresh stability will not be that. This one is just for demonstration. But the point is that it works even inside the VirtualBox. So let me close it. And this one is some first run report. And we could show the package, we could install new package. Let's say in my case, I'll just make it quick again. Apt-get install CyclePy. And as on Linux, maybe you've heard already in some demonstrations that you need to use sudo to install packages on Debian systems if you want to become root. Default password for on this virtual machine, kind of everything is somewhat less protected, but we are not running any services which are exposed online. If this machine gets compromised, well, you just kill that appliance or copy the data out, and then you could kill it and start anew. That's why security is not, I wouldn't say taken seriously, but there is no as many security levels as you want on your stock desktop. So in my case, sudo didn't even ask for the password, and because we had CyclePy installed already, it didn't have to install anything else. What I could do also is upgrade the system. Maybe you saw that one in our tutorial. And this appliance was generated based on Debian 8.0.0, which was released a while back this year. And if I do apt-get dist upgrade, it will say that to upgrade to the most recent release, right, I'll need to fetch these 144 megabytes of archives, and they will get deployed, and everything will work as good because those packages, they have only bug fixes in them. And we could even see, let's say there is another interesting command from from command line, which could be, let's say, we'll use this package, apt-cache policy, which might be handy for you whenever you want to discover what is going on with the package. This one gives a list of versions and archives from where this package is available. So apt-cache policy says that we have this one installed locally, var libc package status, that's local installation, but new versions are available from those archives, right? So we have two new versions available, either from stock Debian or security fixes. So the most recent version will take precedence over the highest priority here. So you could even set up some repositories which will be available, but it will not upgrade to if new version becomes available. So provides this flexibility of managing the system in a little bit more intriguing ways. But for average user, just default installation of NeuroDebian and virtual appliance will be sufficient to keep this system up to date and have recent versions available. Let me demonstrate just one more feature. How do we get, let's say, if you are scared from command line, you could go to settings and, let's say, package manager. And default password for NeuroDebian virtual appliance root is NeuroDebian. So you type NeuroDebian, you authenticate, and now, well, you given a little how to this all works, right? So this software organized in packages. You could click on the package and select which ones get installed, and then you need to hit apply. So let me just demonstrate it. We could search for, I don't know, let's look for neuroimaging, descriptions and name. You could restrict to what looking and search, and it gives us really nice list of many things, right? Let's say many of you probably got to love already Nibable. So let's see how difficult it is to install this one. And it says that to install Nibable, it will install also Python DICOM and Fuse, which are optional dependencies, but by default, once again, those recommendations are included in installation. And then we hit apply. So it again tells us what to be installed, what left unchanged, all those packages which could be updated. And those packages get installed. And now you have them installed. And probably they will have this green mark if you look for Nibable. See, it says this version is installed and this one is latest one available. So installation of the system is really easy, and you could use these Markle upgrades. It will say that, oh, we need to upgrade system, and then you hit apply. It will download those 144 megabytes, and that's how difficult it is to maintain these systems. And I guess on this one, I will conclude my speech, and I would be happy to accept any questions if you have. Let me switch back to the Hangout. Here we go. And switch to, maybe switch off screen sharing for now. Presenting to everyone. How to cancel it? I've forgotten that. Is anybody there? I wonder. Chat, screen share, showcase. Oh, it was a camera. Here you go. Hi, Nolan. Glad to see you, and I hope I'll hear you as well.
Yes, we're all here. Everyone's diligently listening.
Hello, people. Although it froze me. Did you trip the Ethernet cable, I wonder?
Yep, there you are.
You're back.
Yes.
Yarrick.
Camera.
Good, sir.
So if you don't have any questions, I could demonstrate data lab if you want.
Well, we're actually running late now.
Oh, okay.
So we need to move on to the next one. But we, is there any questions on the Gitter? Does anybody here have questions about my Bible and the usefulness of it? The Neurodebian and the usefulness of it? But Yari can answer all questions. Oh, there he is. Okay, well, so we're gonna. So, Yarrick, I think we arranged for you to hang out for a little bit and answer questions that people may have. So, if you wouldn't mind, I'm going to disconnect you from this stream, and that'll end the stream and archive it on the webpage. And then, if you will call me on another Hangout call, and then we'll post that link to the Gitter. And then anybody who's interested in asking Yarrick more about the tools that he's developed or his research or the anything else, y'all can connect and hang out with him. And you know, Yarrick, if nobody connects, maybe just hang out for a little bit and then.
Will be done, sir.
I'll see you soon, sir.
Thank you, everybody, for attention.
All right.